All right, hi there. We are looking at manipulating logarithmic expressions in this segment, and we are focusing on expansion. We're going to take logarithmic expressions and expand them. So, a lot of people think that more is better, and so we're going to take these logarithms and create more of them. Some of you may feel like that's a nightmare. More logarithms, yuck. But that's what we're going to do in this video. We're going to start by talking about what does it mean to expand logarithms. And your textbook or your exercises may say something like, expand the logarithm as much as possible, which I think is a little bit vague and not really descriptive of what we want you to do. So the clues that you're going to use here are, what do we not want to see in our result? Well, we learned 3 rules earlier in some earlier segments, and those are the things that we do not want to see. We do not want to see products in the arguments of our logarithms. We do not want to see any quotients in the arguments of our logarithms, and we do not want to see any powers. So if we keep that in mind, we can decide if we are finished with our process or if we need to take it a step further. So we're going to look at 4 examples together. One thing that often students find helpful, and it works for several of these types of problems, but not necessarily all the time, would be to first apply your product and quotient rule and then apply your power rule. But it's really working from the outside in. If there is something outside that you need to deal with, then you do that first and then apply what is going on the inside. So let's look here at some of these examples. We're going to look at this one first. Log base b of x times y cubed. And the first thing I would say would be to look at that argument, xy cubed, and decide, what do you see? Do you see a product? Do you see a quotient? Do you see a power? Okay, we don't see any quotient, so we don't need to apply the quotient rule, but I do see a product and I do see a power. Okay, so let's apply the product rule first, and that would be separating these 2 factors into separate logs. So log base b of x plus log base b of y cubed. And now I'm looking at these 2 logarithms and seeing, do I see products, quotients, or powers here? And here we do not, yet here we see a power. So here we want to apply the power rule and bring that 3 up and let it function as a coefficient. So log base b of x plus 3 times the log base b of y. And that will take care of that problem. Moving on to this next example, we have log base 6 of 36 divided by the square root of x plus 1. So what do we have? Do we have products? Do we have quotients? Do we have powers? And in this case, we have a quotient. We see the fraction that is functioning as a division symbol. And we also have a power, but it's disguised in the form of a radical. So we would think about this as, instead of the square root of x plus 1, we would think about this as x plus 1 to the power of 1/2. And that is what we'll have to do. So let's first apply the quotient rule, okay? And so we would break the quotient into 2 different logarithms separated by a subtraction symbol. Log base 6 of 36 minus log base 6. And I'm going to go ahead and change this, as we just discussed, to x plus 1 to the 1/2 power. Okay, So now we're going to look at these two logarithms and see if A, they can be simplified, or B, there's something else that needs to be done. And if I'm looking at this piece, log base 6 of 36, I do recognize that 36 is a power of 6, so this can be simplified to just 2 because it is a 6 squared is equal to 36. Minus, and here we have this power we need to get rid of, so we're going to pull that 1/2 out to the front. Minus 1/2 the log base 6 of x plus 1. Now, looking at those logarithms, are there any arguments? Oh, no logarithm left here, right? But here, do we have anything in our argument, what we're taking the logarithm of, that is a product, a quotient, or a power? And the answer to that is no, so we are finished with this one. Remember, it is tempting to want to split up this sum, but there is no sum rule. Only product rule, quotient rule, and power rule. All right, moving on to this next example. We're going to look at this example together. Log base b of the cube root of x times y to the 4th, all divided by z to the 5th. All right, so what do we have going on here? Do we have products, quotients, or powers? And the answer to that question is yes, we have them all. So let's go ahead and write this in separate logarithms for each of the things that we see. We see a product here, so we can break these two things apart, and we see a quotient here. And remember that when we have a quotient, that we can write it as a subtraction, and the denominator piece would be the negative piece. So we can start by just separating these into 3 separate logs. Log base b, and I'm going to write this as x to the 1/3 power because the cube root of x is the same as the 1/3 power, plus this piece right here, log base b of y to the 4th. Okay, and then we're going to, I'm running out of space on this side, so we're going to say minus log base b of z to the 5th. All right, and now we're going to look at each of these pieces and see how they can simplify or apply the power rule. So looking at, we've got variables, so we don't have numerical simplifications that we can make, but we can apply the product or the power rule every single time. So pulling these powers out to the front, we end up with something that looks like this. 1/3 times the log base b of x plus 4 times the log base b of y minus 5 times the log base b of z. And we will say that we're good there. No products, powers, or quotients in any of our arguments. All right, last example for this expansion piece. Okay, so we have ln of x cubed times the square root of x squared plus 1 divided by the quantity x plus 1 raised to the 4th power. And again, in this case, we have products. Here on the top, we have a product of two things. We have quotients because we've got that fraction symbol functioning as a division sign. And we have powers. All the way across, we've got powers. We've got a power of 3 here. This is a power of 1/2 because the square root is a 1/2 power. And we have a power of 4. So let's go ahead and separate our logs. We should have 3 logs. We're going to say ln of x cubed plus ln of x squared plus 1 to the 1/2 power plus ln, I'm sorry, that should be minus, my bad, minus ln of x plus 1 to the 4th. All right. So at this point, we can apply the power rule to all 3 of these logarithmic expressions. And we would have 3 times ln of x plus 1/2 times ln of x squared plus 1 minus 4 times the ln of x plus 1. And looking at our arguments, no products, quotients, or powers here, here, or here, and none of these logarithms can be simplified. So we are done. And that concludes expansion.